Good morning, my dear students. Hope all of you are fine. I am also fine, and all of you are eagerly waiting for coming at the Milestone College campus. And I hope I will see all of your face at the Milestone College campus very soon, inshallah. Dear students, today I am going to discuss about the last topic of organic chemistry. I am in chapter 11. So let's come to the point. Dear students, I discussed in my last lecture about alkane very broadly. Now come to the alkene. What is alkene? Hydrocarbons with carbon-carbon double bond are known as alkene. The general formula of alkene is CnH2n. If I put the value of n is equal to 2, then it will be C2H2 into 2, or it will be C2H4. And if I write the structural formula of this compound, it will be CH2 double bond CH2. I mean, the name of this compound will be ethene. Students, actually in case of double bond, you have to write "ene", and due to the two carbon atoms, it is eth. So the resulting name is ethene. And again, if I put the value of n here 3, I mean n is equal to 3, then it will be C3H2 into 3 or C3H6, or if I write the structural formula of this compound, it will be CH3 bond CH double bond CH2. As there are 3 carbon atoms, it will be prop, and due to the carbon-carbon double bond, it will be ene. So the resulting compound is propene. Now if I write here n is equal to 4, so it will be C4H2 into 4, or it will be C4H8, or it will be CH3 bond CH2 bond CH double bond CH2. Dear learners, there are 4 carbon atoms in this compound, that's why it is butte. And the position of carbon-carbon double bond is at the first carbon, that's why it is butene. You have to start the numbering from the right side of this formula, because if I count the number of carbon atom from the right side, the position of carbon-carbon double bond will be at the lower carbon. That's why I have to start the numbering from the right side of this formula, and the resulting name is bute due to the carbon-carbon, due to the number of carbon atoms 4, and ene due to the carbon-carbon double bond, and hyphen 1 means the position of carbon-carbon double bond is 1 carbon. That's all about the nomenclature of alkene. Alcohol reacts with concentrated sulfuric acid to produce alkene. Here I have used ethanol as example, and ethene is the example of alkene here. Actually, one molecule of water is absorbed by concentrated sulfuric acid. Dear students, to make you understand easily, I would like to show you the structural formula of this reaction. I can write the ethanol like this, CH2 and one hydrogen I can write separately, and this is CH2, and also I can write the hydroxyl group at the upper side, and then concentrated sulfuric acid. Dear learners, you know that in the aqueous solution, when the amount of sulfuric acid is higher than that of water, then it is known as concentrated sulfuric acid. And you know that concentrated sulfuric acid is a dehydrating agent. It means concentrated sulfuric acid absorbs water from the another substance, and here actually this hydrogen atom combines with OH group to produce water, and this water is actually absorbed by concentrated sulfuric acid. So I can write here H2SO4 plus H2O. Dear learners, if you observe the reaction, we will see that in this case two bonds are break. So when two bonds break, there will be a new bond, and already there is a carbon-carbon single bond, and due to the breaking of two bonds a new bond is formed, and that's why I have given here a new bond, and the name of this compound is ethene. This is actually the short presentation or short mechanism of this reaction to understand easily and clearly. And if I increase the another carbon, then what will happen? I mean, if I take propanol, dear students, I can also write the propanol like this, and if I use concentrated sulfuric acid as well as the previous reaction, then here actually this hydrogen atom combines with OH group to produce water. Then I can write here H2SO4 plus H2O, and due to the breaking of two bonds it will be a new bond CH2, and the another part of compound will remain unchanged. Dear students, here already one bond is given, and due to the breaking of two bonds a new bond is formed. That's why I have given the new bond in red in color, and the name of this compound will be probe. Due to the 3 carbon atoms it will be probe, and due to the carbon-carbon double bond it will be ene, and the name of this compound is actually propane. From alkyl halide, if I write here an example of alkyl halide, suppose ethyl chloride. This is ethyl chloride, and ethyl chloride reacts with alcoholic sodium hydroxide. I mean, this sodium hydroxide is dissolved in the alcohol, then alkene is produced here. Actually here the alkene is ethene, then water, then sodium chloride. Dear learners, I would like to display this reaction again with the partial structural formula to make you understand easily. Now look at the whiteboard. Now again I am going to write this reaction. Actually I am going to write one hydrogen atom separately. That's why this is H, and this chlorine I am going to write at the upper side of the formula. Then alcoholic sodium hydroxide is given here, and actually this chlorine combines with sodium to produce sodium chloride, and this hydrogen atom combines with OH to produce water. And from this formula it can be seen, it can be understood easily, two bonds are break here. That's why another new bond will form. CH2 bond CH2. Dear students, I have given here only one bond, and this bond is actually formed previously, but newly the two bonds are break to form another new bond. That's why it will be CH2 double bond CH2, and the name of this compound is ethene. This is actually the bond breaking and forming process of this reaction, dear students. As well as if I increase the number of carbon atom, same reaction will occur. In case of 1-chloropropane, CH3 bond CH2 bond CH2 bond Cl plus alcoholic sodium hydroxide, then propane is produced here as alkene plus water plus sodium chloride. Dear students, that's all about the preparation of alkene from alkyl halide. Again, if I heat alcohol with aluminum oxide catalyst, then alkene is also produced. That's why I can write here alkene can be also produced from alcohol. Here actually I am going to use ethanol as alcohol. Ethanol is heated with in the presence of aluminum oxide to produce ethene. Here actually one molecule of water is reduced from the ethanol. That's all about the preparation of alkene. Now I am going to show you the chemical reactions of alkene. Water addition. Ethene reacts with water at high temperature in the presence of phosphoric acid catalyst to produce ethanol. Dear students, I would like to show this reaction again as structural formula, as this is a This is an alkene. It contains carbon-carbon double bond, and the another reactant is actually water. I have written water as partial structural formula. Then in the presence of phosphoric acid at high temperature, one bond of ethene is break to form another two new bonds, and hydrogen atom of water combines with this carbon, and OH of water combines with another carbon, and as a result it is C2 plus 1, I mean CH3, CH2 OH. I have written here the OH at the forward side of this formula. Addition of hydrogen. Ethene reacts with hydrogen in the presence of nickel catalyst at 180 to 200 degree centigrade temperature to produce ethane. Dear students, again I would like to show you this reaction as structural formula. Ethene reacts with hydrogen atom in the presence of nickel catalyst and 180 degree to 200 degree centigrade temperature. One bond of ethene is breaked to form another two new bonds, and two hydrogen atoms combine with one hydrogen atom combined with one bond, and another hydrogen atom combined with another bond, and the resulting formula is actually CH3, two hydrogen atoms and one hydrogen atom, total three hydrogen atoms. That's why this is CH3 and this is also CH3, and the product is CH3 bond CH3. This is known as ethane. And if I increase the number of hydrogen atoms, what will happen? I mean, I would like to write here propene, and hydrogen gas is passed in the presence of nickel catalyst at 180 degree to 200 degree centigrade temperature. Then there is a carbon-carbon double bond, and one bond is break to form another two new bonds, 1, 2, and two hydrogen atoms combined with two new bonds, and I can write this compound as CH3 bond CH2 bond CH3. This is actually propane, and the name of this compound is propene. Actually, dear students, I would like to say you, whatever the number of carbon atoms, it's not my headache. I have to focus on the changing point of reaction. Here the changing point of reaction is carbon-carbon double bond. Between two bonds, one bond is breaked to form two new bonds, and those two hydrogen atoms combine with two new bonds. Here in case of propene, also those two carbon atoms only take part in the change. Here one bond of carbon-carbon double bond is break to form another two new bonds, and two hydrogen atoms combined with two new bonds. That's all about the addition of hydrogen with alkene. Dear learners, all of you know that alkene is an unsaturated hydrocarbon. You know that the hydrocarbons which contain carbon-carbon double bond or triple bond are known as unsaturated hydrocarbon. Now my question, how can you understand that this is an unsaturated hydrocarbon? That's why I have two tests in the laboratory. One is bromine water test or bromine solution test. Bromine solution test. Actually, all of you know that bromine is red color liquid substance, and here if I consider ethene in the presence of carbon tetrachloride, if I add red color bromine with ethene, the red color becomes disappear and 1,2-dibromo ethane is produced here. Actually, the discolorization of bromine solution confirms the presence of carbon-carbon double bond. Again, if I show you the another example, this is propane, and the product will be CH3 bond CH2. This is 1,2,3 1,2-dibromo propane. And the second test is Bayer test. If pink color alkaline potassium permanganate is added with alkene, then the pink color of alkaline potassium permanganate will disappear, which confirms the presence of carbon-carbon double bond, I mean unsaturation. So here the product will be one bond is break to form another two new bonds, and one hydrogen atom from water, and the nascent oxygen will be OH, and another remain OH of water will combine with this carbon. So the name of this carbon is 1,2-ethane 1,2-diol. This is the formula of ethane 1,2-diol. And again, if I write here propane, water plus nascent oxygen is equal to potassium permanganate plus potassium hydroxide, then it will be CH3 bond CH bond CH2, another two new bonds are formed here, and one hydrogen atom and a nascent oxygen will be OH, and the remaining part of water is OH. So the name of this compound is 1,2,3 1-propane 1,2-diol. Dear students, due to the hydroxy group, and actually those are alcoholic OH, due to the alcoholic OH it will be all, and as there are two alcoholic OH, that's why I have written here di, and the positions of OH groups are 1 and 2 non-carbon atoms, that's why I have written here 1, 2, but it is stated that if I write two digits side by side, there will be a comma sign between two digits, and if I write any digit after any word, in that case there will be a hyphen in between the digit and the word. This is actually the nomenclature method of IUPAC. Ethene is more reactive than ethane in the addition reaction. Dear students, all of you know that Ethene contains carbon-carbon double bond and ethane contains carbon-carbon single bond. And actually ethane is a saturated hydrocarbon and ethene is an unsaturated hydrocarbon. Between two bonds, one bond is very weak bond. Dear students, will study it in higher class. One is sigma bond and another is pi bond. But I would not like to discuss about sigma bond and pi bond. Just remember it. Between two bonds, one bond is weak and another bond is strong. The weak bond can be broken easily, and already I have told you in my previous question, one bond will break to form another two bond and it can take part in the addition reaction very rapidly. That's why I can say ethene is highly reactive in addition reaction. But in case of alkane, I mean here ethane contains carbon-carbon single bond. As it is a saturated hydrocarbon, it is very stable. That's why it would not like to take part in the chemical reaction very easily. That's why I can say ethene is more reactive than ethane. Dear students, alkenes are also known as olefins. Olefins means oil producer. If I write here a chemical reaction, ethene reacts with chlorine to produce 1,2-dichloroethane. 1,2 there are two chlorine atoms, that's why it will be dichloro, and due to the two carbon atoms it will be ethane, so it will be 1,2-dichloroethane. And 1,2-dichloroethane is actually look like a oily substance, that's why the alkenes are known as olefins. I mean alkenes react with halogen to form oily substance, and the Latin name of oily substance is actually olefins. So dear students, that's all about the alkene, and no more today. Inshallah, I will discuss about this chapter again in my last lecture.